In this particular study, it was a huge collaboration, where especially, for example, let's just look for at the funding. Right off the bat, there were a ton of researchers involved in this exploratory, or I should say, discovery per se. Now, what we have here is we have a correlation between a nicotinamide adenosine dinucleotide plus, I know it's a little complex, and something called epithelial V-like antigen 1 homolog C complex. In simplistic terms, it is like this. You take a cordless power drill, and the battery pack is the NAD plus, and the power drill is the EVA 1C. And so what you have when you combine the two, you have, how would you say, a very powerful corrective force in regard to RNA splicing. I know it's a little detailed in regard to the doing this on YouTube, but the outcome is astounding and offers an incredible amount of promise in Alzheimer's disease. So without further ado, let's get right into the study itself. Nicotinamide adenosine NAD plus restores memory in Alzheimer's disease models by correcting RNA errors. So this is kind of like a new discovery overall. So we look at the initial chart. There you have it right there. You see, as far as the different stages of Alzheimer's disease in this animal model, when this either a nicotinamide mononucleotide or nicotinamide riboside is decreased, it results in the deficit of nicotinamide adenosine dinucleotide NAD+. And then it basically, you can't power the EVA1C, which helps with RNA splicing. So let's get right into this. I'm going to keep it as simple as I possibly can, and let us begin. All right, preliminary studies show NAD plus restores memories in Alzheimer's disease models by correcting RNA errors. To reiterate, preliminary studies have shown that supplementation with NAD plus precursors such as nicotinamide riboside or nicotinamide mononucleotide can offer therapeutic benefits in Alzheimer's disease models and early clinical trials. The new study reveals, and please forgive me if I'm speaking fast, a lot of territory to cover, that NAD plus works through a previously unidentified RNA splicing pathway. This pathway is regulated by a protein called EVA1C, I'll say it that way for short, which plays an essential role in the processing RNA splicing. RNA splicing allows a single gene to produce multiple isoforms of a protein, and one isoform may show distinctive effects to other isoforms. Its dysregulation, broken, not working properly, can't spell check, is one of the most recently acknowledged risk factors for Alzheimer's disease. The researchers discovered that when NAD plus levels are increased, this EVA1C helps correct mistakes in RNA splicing. In this case, we call it a spell checker, and the NAD plus is kind of the battery that powers that spell checker. The restoration process improves the function of hundreds of genes, many crucial for brain health, which can help reverse the neurodegenerative damages caused by tau protein. Strong claim. So let's look at it real fast in charts. All right, look at this. Let's just give an example of the toxic tau protein buildup in regard to healthy mice. All right, so you get a little idea there, and they begin to define this discovery in regard to the EVA1C. And then it gets even more interesting. Let's proceed forward. Look at this. When this case in the animal model, when they introduced nicotinamide mononucleotide, they found, look at the levels of correction, especially bar chart number 1 there and bar chart number 2. It brought it to healthy levels. Now, when they interfered with the epithelial V-like 1 antigen 1 homolog C, they found that it couldn't work. So that was the battery pack to the spell checker. When they took the spell checker out, the battery pack obviously did nothing because it had nothing to power. All right, and then you look at the link itself when they began to make this discovery. They looked at worms as well, different life forms, replicating kind of like the same effect, and that gives you a simple breakdown of how it does its job. Now, as we go back into the study itself, here we go. Towards a new Alzheimer's treatments. And again, I'm quoting here. By establishing the connection between NAD plus and the epithelial V-like antigen 1 homolog C, EVA1C, the study lays the groundwork for the development of new therapies and optimization of NAD plus augmentation strategy in humans. Kind of fragmented there, but still. Quote, we propose that maintaining NAD plus levels could help preserve neuronal identity and delay cognitive decline, paving the way for combination treatments to enhance RNA splicing. And the researcher is AI, but it's not AI. And there it basically has your conclusion from the researchers. To go a little bit deeper into it, as far as technical-wise for the healthcare professionals and the other researchers, I brought this chart up there. Freeze it for a second if you like to, if you want to go into more detail. And then to bring it all home, let's look at the implications for healthcare and research. I'm going to leave that for the professionals to read on their own. But even easier, the takeaway section right there, which gives you a really good, comprehensive, simplified view in regard to the NAD plus or NAD plus precursors, nicotinamide mononucleotide, nicotinamide riboside in this case, NMM or NR, in regard to the epithelial V-like antigen 1 homolog, whatever, in regard to helping correct this RNA splicing error. And so, also too, just for fun, I want to give you an idea of the size of this research. All right, there we have basically a little bit from our abstract. Show you a little bit more detail in regard to the math involved, which I'm always fascinated with. And once again, the funding, a lot of people looking at this research because it is quite groundbreaking. So you have to give a lot of credit. This is extremely thoughtful, basically expanding the horizon in potential treatments for this challenging, basically I should say challenging ailment in a lot of individuals. And something simple as far as correcting the RNA splicing and helping the EVA1C protein do its job, because the NAD plus powers this thing. And then the RNA goes, ooh, I've been making a mistake, and starts correcting the errors in its production on its just by doing its own thing, just by adding the nicotinamide adenosine dinucleotide plus precursors in there. It just seems to start working, at least in this animal model. Again, gratitude to the researchers. Phenomenal discoveries. I am humble you watch, and looking forward to see what you and I both discover next week. Again, gratitude to all of you. I'll catch you all next time. See you then. Bye.